Hey guys, we are from Platinum and our group topic is mathematical induction. I'm Amar.
I'm Putri.
I'm Vincent. I'm Muhammad Azmi.
So, what are we waiting for? Let's go.
Go.
Hello, my name is Vincent. Today I'm going to talk about mathematical induction, which is our group. We will discuss this. So mathematical induction is a mathematical technique which is used to prove a statement, a formula, or a theorem is true for every natural numbers. Secondly, what is induction? So, induction means, mathematical induction means a proof of a method of proving. It doesn't not generate answers. It only can prove them. There are three types of mathematical induction, which is base cases. Base cases show it is true for one element. Number two is induction hypothesis. That means assume it is true for any given element. Must be clearly labeled. Number three is show that if it true for the next highest element. There have some of the induction examples given below. So I will talk about some of the examples, which is so that n is less than 2 to the power of n for all positive integers n. Like therefore, let P bracket n be the position n less than 2 to the power of n. In the base case, there have shows that one of the examples shows that P bracket 1 bracket is true. P bracket 1 is true because 1 is less than 2 to the power of 1, which is equals to 2. So there mathematical induction is the techniques which we are going to improve or prove that all values of any given number, any natural number is true. That's it. Thank you very much.
Hello, I'm Putri. Today I want to share you about arithmetic sequence. So here I put the formula to find the n term of arithmetic. The formula is a sub 1 plus n minus 1 times d. A sub 1 is gonna be represent the first term, and if you want the n term, you plug in the number n minus 1. And d is the common difference. Here some examples: 3, 8, 13, 18, 23, 28, and etc. This number called arithmetic sequence. And they are different by 5, so that is our d value. Here the first term is 3. We call that our generically a sub 1, and 8 is a sub 2, 13 is a sub 3, and continue. So let's see if we can find or justify. Did you still remember our formula? A sub 1 plus n minus 1 times d. So that we say our first term is 3, so it's called as a sub 1. Well, our second term equal to 8, so incorporate the d value. Such as 3 plus 3 minus 1 times D equal 8. 8 5 because that what they are different. So by A sub 3 is 13. How to calculate is 13 equal 3 plus 3 minus 1 times D. So it becomes 13 and so forth by A sub 4, A sub 5, A sub 6 and etc. That's all from me.
My name is Azmin and my subtopic today is geometry progression. Geometry progression is also called geometric sequences of a number which differ from its of by a common ratio. By example, sequences 2, 4, 8, 16 and other is a geometric sequences with common ratio 2. We can find the common ratio between only two adjacent terms. Describing geometric progression are important terminology. Important terminology have two. First, integral term. Second, common ratio. Integral terms. In a geometric progression, the first number is called the integral term. Common ratio, the between a term in the sequence and two terms before it is called common ratio. Recursive formula. You can describe a geometric sequence with a recursive formula. This of each term relate to one before signs in a geometric progression. Each term is given by the product of the previous term and the common ratio. We can write a recursive equation as follows: term equal previous term multiply common ratio. More precisely, the common ratio are we have a sub n equal a sub n minus 1 multiply r. Explicit formula. If we know the integral terms, the following terms are related to it by repeat. Term equal integral term multiply common ratio multiply common ratio multiply common ratio and so on. Using exponent, we can write this with a condition ratio. A sub n equal a1 multiply r equal n minus 1. Using exponent, we can write this with common ratio using a sub n equal a1 multiply r to power n minus 1. Example geometric progression in real life. A population growth in which each people decide not to have another kid based on current population. Then population growth each year is a geometric. Each radioactive independently disintegrate, so each will have its fixed decay rate, so it is also geometric.
Assalamualaikum, I'm Amar. For our group mathematical induction topic, I'm going to talk about the Tower of Hanoi. So, what is the Tower of Hanoi, you may ask? So, basically, the Tower of Hanoi is a game that was invented by a French mathematician. Tower of Hanoi is a stack of discs that arrange on top of each other from a large size to a smaller size. So, basically, the rule of the game is you need to move all the discs from the Tower A to the Tower C, and you must move it one by one. And at any moment of the time, you can put a larger disk on a smaller disk. So basically, the disk can be as many disks on the tower. Maybe you're wondering how to play this game. Well, basically, there is a way to solve this problem by taking a small example. If there are only one disk, the way to solve it, basically, we just need to put the disk at the tower A and move it to the tower C. Next, how about if there are two disks? Well, we will need to move the disk to the tower B first. Next, you move the second disk, move it to the tower C, and then you pick up the first disk on the tower B and move it to the tower C. So, you will solve the problem. If the disk is in a small number, the solution will be easy. So, now, how about we give 3 disks? So basically, the way to solve it is, the first step, you need to move the first disk to the C. Next, you need to move the second disk to the B. The third way, you need to move the third disk on the tower C and pick up the first disk to the tower A back. Then you need to pick the second disk on the tower B and put it back to the tower C, and then pick up the first disk and put it back to the tower C. That's the way how to solve if there is 3 disks. As we can see, the number of moves just keep increasing by depending on the number of disks that been given to us. We can calculate the number of moves depending on the number of disks using the mathematical induction. Well, basically, the formula is m parenthesis n equal to the power of n minus 1, where m is the number of moves and n is the number of disks. Here are the number of moves needed to solve the Hanoi Tower depending on the number of disks. Test this formula. For example, if we use 7 disks, so the equation will be like this. Hence, we prove our induction. That's all from me. Signing out for now. Thank you.
My name is Muhammad Azmin. My nickname is Azmin Kacang.
Okay, so we start and then we will introduce each of us and we will walk away. Okay. Hey guys, we are from Platinum and our group topic is mathematical induction. I'm Amar.
I'm Putri.
I'm Benson.
I'm Muhammad Azmin.
So, what are we waiting for? Let's go.
Oh, you don't.
And A is A sub 2. So that is our D. Is bit. Plus n minus 1 times D.
Of the previous term and the common ratio, which means write a recursive section as follows. Betul apa? Tak nampak?
Sambung je lah. Kemalah tekan.
Term equal by previous item. More consciously, you should common ratio of F.
Nice.
Baca tak? Nak masuk YouTube tak? Tu, number plate tu.
3.
Assalamualaikum. I'm Amar.
Kau bodoh.
Jangan stop. Ingatkan kosong. Apa tu?
And the formula analytic formula. If you know the symbol.
Tak macam benda ni. Dia benda ni aku tulis kat bawah. Initial term. Initial.